Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to solve problems about the pressure at a point inside a liquid. At the first, we have two vessels S and T are filled to the same level with the same liquid as shown in the figure. Show which statement is correct. Since they are filled to the same height and they containing the same liquid of the same density, so the pressure is the same. Which of the following graph show the total external pressure acting on the submarine at different depths below the surface? At the first, the submarine is externally exerted by two pressures, the pressure of water and the atmospheric pressure. So the total external pressure acting on the submarine is the atmospheric pressure plus the pressure of water, and extremely it is exerted from internal by PA, atmospheric pressure. So you must know that the submarine is exerted from external by the atmospheric pressure plus pressure of water, and from internal is exerted by the atmospheric pressure PA. Four identical graduated cylinder contains liquid. Two containers, water of density 1000 kilogram per cubic meter, and the other two contains paraffin oil of density 800 kilogram per cubic meter. Which cylinder has the least pressure exerted on the base by which the liquid is contained? Since the pressure is directly proportional to the density, so the least pressure, the least density. And the pressure also is directly proportional to the height, so the least height, the least pressure. So the least pressure is graduated cylinder number 4. An engineer designs a dam wall of reservoir as shown in the figure. Which factor determine the pressure at X? This is the pressure at the point X. That indicates the depth of the water. Pressure is directly proportional to the depth of water or the height. Four different liquids are poured into identical measuring cylinders. The diagram shows the depths of the liquid and their densities. Which liquid causes the largest pressure on the base of its measuring cylinder? By determining the pressure equals rho Hg. This is the pressure of the first graduated cylinder, the pressure of the second cylinder, pressure of the third cylinder, and notice that we convert kilogram per cubic centimeter to gram per cubic meter. And the height, this is the pressure of the fourth cylinder, and we convert also the heights from centimeter to meter. Then which one is the more pressure is cylinder letter C. What doesn't affect the pressure at a point beneath the surface of a liquid? The pressure beneath the surface of a liquid doesn't depend on the area. Pressure equal rho Hg. Pressure at a point inside a homogeneous static liquid has all the following properties except which is the false one. Pressure depends on the area. No, pressure doesn't depend on the area. This is the false statement. The opposite figure showed the graph relation between the pressure at a point inside the liquid, enclose the container and the vertical distance h. Since the relation indicates rho g, so the slope equal P over H, that is equal rho G, and here the slope equal tan theta, then the opposite figure shows a lake which contains water. So the graph relation that represents the pressure of water at the point 1 and 2 and 3 on the y-axis and the depths on the x-axis. As the height increase, the pressure increase. As the height or the depths of water increase, the pressure increase. So the relation is letter P. A chip float on the surface of a seawater as shown in the figure. If the point A, B, C are under the surface of water, so we know that in all the points that lie in the same horizontal plane of the same liquid acted by equal pressure, then the pressure at the point C is less than the pressure at the point A that is equal to the pressure at point B. The following figure shows two water containers. One of them contains fresh water and also contains salty water where the density of salty water is greater than the fresh water. Since the pressure is directly proportional to the density and also directly proportional to the height, so the highest pressure at the deepest point in the largest density, the point D. The opposite figure shows three vessels of different shape. They are filled with water to the same level and they have the same phase area. Which of the following statement is correct for these vessels? They are containing the same water, same density, same height, so the pressure is the same. Mariana Trench is the deepest trench in the world, which is located in the western Pacific Ocean at a depth of 11 kilometers. If the water density of the ocean is 1020 kilogram per cubic meter, and the pressure of the water at this depth is nearly equal to pressure equals rho hg, then 1020 times 11 times 10 power 3 to convert it from kilometer to meter times 9.8 approximately equal 1.1 times 10 of power 8 Pascal. The opposite figure shows a water sink whose depth extends from 20 centimeter to 30 centimeter. So the pressure of the water which affects a stopper at the bottom of the sink at the depth of 30 centimeter equal to pressure equal rho hg, and we must convert the height from centimeter to meter times 10 power negative 2, then the pressure is 2940 Pascal. A thin plate of surface area 0.036 meter square is placed horizontally under the surface of a liquid of density 930 kilogram per cubic meter. If the force that acts on the upper surface of the plate due to the liquid pressure is 290 Newton, so the depth of the plate under the water surface is at the first pressure equal force divided by area. Then the pressure exerted by the water or the liquid on the thin plate is 8055.5 Pascal, where the pressure equal rho hg, then h equal P over rho g. Then the height is 0.88 meter. Fish tank has a shape of cuboid whose base dimension is 80, 60, and 40. Water is poured in the tank until it reaches the height of 30 centimeters. The force due to the water pressure, which act on the bottom of the sink equal. At the first, pressure equal rho hd 1000 times 0.3, the height of water, not the height of the tank, times 9.8. This is the pressure. Then the force equal PA, that is equal the pressure times the area of the tank. Submarine has settled down at depths of 400 meters under the seawater of density 1025 kilogram per cubic meter. So the pressure difference on its wall is, at the first, the pressure difference equal the pressure of water. The submarine is at a height or at a depth 400 meters. So delta P, pressure difference, equal rho hg. If the atmospheric pressure at the sea level is 100 kilopascal and the density of seawater is 1020 kilogram per cubic meter, at which depth from the sea level does the total pressure equal 110 kilopascal? The pressure difference between the points is 100 kilopascal and at the other point is 110 kilopascal. So the pressure difference delta P equal rho hg. Then the pressure difference 110 minus 100 times 10 power of 3 to convert it from kilopascal to pascal equal the density times the height times 9.8. So the height is 1 meter. A cubic tank of side length 100 centimeter is opened from the top. If the water is poured inside the tank to a height 20 centimeter, then gasoline is added to a height 80 centimeter from the bottom of the tank. So the pressure difference between the points at the surface of gasoline and another point at the interface between the water and the gasoline. This is the tank. 20 centimeter of water, then 60 centimeter of gasoline. Then the pressure difference between these 2 points is delta P equal rho hg. This is the pressure of gasoline. Then the pressure is 900 times 0.6 times 10. 60 times 10 power negative 2 equals 0.6. Then the pressure difference is 5.4 times 10 power of 3 Newton per meter square. A tank of height 120 centimeters is filled completely with water of density 10 power 3 kilogram per cubic meter. If 1/3 of the water volume is taken out from the tank, then 2 equal volumes of immiscible liquids, which are immiscible with water also, are poured in the tank until the tank gets filled. If the relative density of the two liquids are 0.8 and 1.2, then the percentage of the change in the pressure at the bottom of the tank at the first, the relative density of the substance, one is 0.8. So the density equal relative density times 1000. That is equal to 0.8 times 1000 equal 800 kilogram per cubic meter. The density of the second substance equal to relative density times 1000. That is equal 1.2 times 1000 equal 1200 kilogram per cubic meter. In the first case, the tank was completely filled with water. And the second case, 2 equal volumes are filled with the tank with water. Then the pressure in the first case pressure equal rho hg. Rho density of water times the height of water 1.2 meters times 9.8, then the pressure is 11,760 Newton per meter square. While in the second case, the pressure that exerts the bottom of the tank or acting on the bottom of the tank is the pressure of the three liquids. Then the pressure equal rho Hg1 plus rho Hg water plus rho Hg the second liquid. By substituting the numbers, then the pressure in the second case also equal 11,760, then the pressure difference equal 0. In the opposite figure, H2 equal. Here is a container that contains a liquid, and from the middle there is an opening that's open between the water and the water. Then the pressure that acts in all the points that lie in the same horizontal plane of the same liquid is equal. Again, here is an opening that opened the water to water or connected the water with water. So the pressure that acts at the 2 points that lie in the same horizontal plane of the same liquid acted by equal pressure. So at the left side, the pressure acting on the left side is PA plus P oil plus P water, equal to the pressure exerts on the right side, PA plus P water. Cancel PA with PA, then P oil plus P water equal P water. Then rho Hg of oil plus rho Hg of water equal rho Hg of water on the right side. Then cancel G with G, then the density of oil given 840 times the height of oil H2 plus density of water times the height of water 3 meters. On the other side, density of water times the height of water 4 meters, then H2 equal 1.19 meters. The opposite figure shows 3 vessels of different shape. Each of them contains a liquid of height h. If all vessels are placed on the same horizontal plane, so the vessel in which, at the first, here is the 3 vessels. The force of the liquid that acts on, or the force that acts on the base of the container in the first vessel, the force that acts on the bottom of the container of the first vessel, second vessel, the force that exerts the bottom of the container is greater than the weight of the liquid inside the container, like that. Then the force is more than the weight of the liquid, or the weight of the liquid inside the vessel is less than the force. But in the third vessel, the force acts on the bottom of the container is less than the weight of the liquid inside the container. So the weight of the liquid is more than the force exerting on the bottom of the container. Let's read. The weight of the liquid equal to its pressing force on the bottom of the vessel is. Which one is equal? Chain number 1. Second question. The weight of the liquid is greater than its pressing force on the weight of the container. The weight of the liquid that is less than its pressing force on the bottom of the container is figure number 2. The opposite figure shows a vessel contains a liquid which is exposed to the atmospheric pressure. If the total pressure which affects the point X is 1.5 atm. atm is a unit of measuring the pressure. Indicates atmospheric pressure. atm, atmospheric pressure. So the ratio between the pressure at the point Y and the Z. At the first, the atmospheric pressure has a unit atm, and the normal atmospheric pressure equal 1 atm. The pressure at the point X equal 1.5 atm. Then what is the pressure at the point X? It is the pressure, atmospheric pressure, plus the pressure of water above the point X. So 1.5 equal 1 plus rho Hg. So the pressure above the point X at the height h equal 0.5. Let's see. This is the container. The pressure from above is the atmospheric pressure. The pressure of the liquid above the point X that has a height h is 0.5. Also the pressure above the point Y of the same height h equals 0.5, and the pressure above the point Z equals 0.5. So the pressure Y divided by pressure Z equal above the point Y, above the point Y, PA plus PX plus BY. Above the point Z, BA plus PX plus PY plus BZ. Then BA plus rho HGX plus rho HGY above or divided by PA plus rho HGX plus rho HGY plus rho HGZ. Then rho Hg equals 0.5, rho Hg equals 0.5, rho Hg equals 0.5. So the pressure or the ratio Py divided Pz equal 2 over 2.5, that is equal 4 over 5. The opposite figure shows the height of water and the petroleum oil as in a well of depth 2000 meters. If the total pressure of the two liquids at the bottom of a well is 17.5 megapascal 10 power of 6, and the density of both water and petroleum oil is 1830 kilogram per cubic meter. So the height of the oil is, at the first, the total pressure exerting on the bottom of the well is the pressure of oil plus pressure of water. So rho Hg of oil plus rho Hg of water. Since the total pressure equals 17.5 times 10 power of 6 to convert from megapascal to pascal equals density of oil times the height of oil times G gravity plus density of water times the height of water equals the total height minus the height of oil. The height of water h equals the total height minus the height of oil h. Then two containers are opened from the top. The first contains liquid X of density 800 and the second contains liquid Y of density 1200 kilogram per cubic meter. Which of the following choices represent the depth of the liquid in each container at which the pressure of the two liquids becomes equal? The pressure is equal, then the pressure Px equals the pressure Py, then rho Hg of X equal rho Hg of Y. Then cancel G with G, then the height of X divided by height of Y equal density of Y divided density of X. Then the ratio is 3 to 2. Which one represents 3 to 2? 15 to 10. When measuring the pressure of oil at height 5 meters from the bottom of an liquid oil container, it found to be 6.75 times 10 of power 4. And at a height 7.5 meters from the bottom, it found to be 4.5 times 10 power of 4. If the acceleration due to gravity is 10, so the density of oil is. At the first, this is the container, contains oil. The height is 5 and 7.5 from the bottom. This is the pressure, and this is the pressure. So the pressure difference between the 2 points is delta P equal rho Hg. Delta P, the difference between the two liquids, equal rho hg. H, the difference between the height. 7.5 minus 5 equal 2.5. So the density of the oil is 900 kilogram per cubic meter. If pressure at half depth of a lake is equal to 2 over 3 pressure at the bottom of the lake, then what is the depth of the lake? Let's see. This is the lake. The total height of the lake is h. The total to the half at half its depth is half h, and the lake is exerted to the atmospheric pressure. So the pressure at half equal to 2 over 3 at the bottom. The pressure at half depth equal PA plus half Hg equal 2 over 3 PA plus rho Hg. Then PA plus half rho Hg equal 2 over 3 times the bracket 2 over 3 PA plus 2 over 3 rho Hg. Then by substituting the number, transfer 2 over 3 PA on the other side and half rho Hg to the other side. Then third PA equal 1 over 6 rho Hg. Then the height equal 2 times PA over rho G. We have the value of PA 10 power of 5, G 1000, the gravity equal 10, then the height equal 20 meters. A beaker contains water with a floating ice cube. If the ice cube melt, the pressure at the bottom of water, since the pressure equal the weight divided by the area, and the weight doesn't change, and the area also of the beaker doesn't change, so the pressure remains constant. Two miscible liquids are put above each other. The graph, which may possibly represent the change in the pressure at a point with respect to the depth of the liquids is. At the first, we can imagine that this is the two liquids above each other. Then you can say that rho 1 is more than rho 2. Then the slope that indicates rho 1 is greater than the slope that indicates rho 2. And they are exposed to the atmospheric pressure. The first case, this is the graph represent one liquid that is exposed to the atmospheric pressure. One liquid that is exposed to the atmospheric pressure. This is the point that indicates atmospheric pressure. Second liquid, this is the constant pressure and exerted by increasing the pressure, constant 1. This is the atmospheric pressure and the straight line, and this is the straight line. The straight line here indicates the density of the first liquid is greater than the straight line that indicates the second liquid. Let's see. Since in rho 1 more than rho 2, in this graph, the slope of a straight line, the first straight line, is greater than the slope of the second straight line. This means that the density rho 1 is greater than the density rho 2. Large slope that indicates rho 1, large slope that indicates rho 2.